Let's solve lead code 1346. Check if n and its double exist. Given an array ARR of integers, check if there exist two indices I and j such that I is not equal to j and array I is equal to 2 times array j. Here's an example. We have 10, 2, 5, 3. As you can see, we have 5. And if you double it, you get 10. Both of them exist in the array, so the answer is true. And if you look at this array, there are no numbers with its double in the array. So the answer is false. Let's see how we can solve this problem. The idea is as we walk over the elements of this array, we are going to insert them into a set so that we can do the search operation. So initially the set is empty. We process 10 at the beginning. We asked if 20 exists in the set so far. No. If 5 exists in the set. No. So I insert 10. Now I process 2. The question I should be asking, have I seen 4 or 1 so far? And I ask the set, have I seen 4? No. Have I seen 1? No. So I insert 2. Now I process 5. The question I should be asking, have I seen 20? I'm sorry, 2 times 5, 10. Yes, 10 exists in the set, so I'm going to return true. So let's look at the next example. 2, the set is empty. Have I seen 4 or 1 so far? No, so I insert 2 into the set. Now 4, have I seen 8? No, but have I seen half of this number, which is 2? Yes, 2 exists in the set. That means I'm going to return true. If you look at here, uh, initially 3, have I seen 6? No. Have I seen 10? No. And have I seen, if when this is an even number, I'm going to ask, have I seen 16 and half of it, which is 4, and none of them exist. So I insert it, and because processing of all of these numbers are finished, I am done. One thing you should be aware is the following. When you are processing an odd number, you should not ask for if the half of this number exists, because then you might conclude by mistake that 5 and half of this number exists in the array. For example, if this was 253 and I was walking over this array, obviously initially this is empty, so I asked, this is an even number, so I am asking if 4 and half of it, which is 1, exists in the set. It does not, so I insert 2. But when I insert 5, I should only, because this is an odd number, I should only be asking if double of this number, which is 10, exists in the set, which it does not. But if I ask, does the half of this number exist? Because this is an integer division, 5 divided by 2 is going to be 2, and 2 already exists in the set. So by mistake, you might conclude that 5 and half of it exists. It cannot, because an odd number cannot have its half in the initial portion of this array. So we only ask if half of this number, the number that we are processing, exists only if it is an even number. And here is the code. So I create a hash set at the beginning. I walk over the array, the integers in the array in the forward direction. The first question I asked is, does the double of this number, so twice the number, exist in the set so far? So among all the numbers that I have seen so far, have I seen twice double of this number? If I did, I return true. Otherwise, I ask if half of this number exists, but only if this number is an even number. If it is odd, I cannot ask that question. So if the number is even and I have seen half of this number before, that means I'm going to return true, because half of this number and its double already exists in the array. Otherwise, I insert it into the set and move on. If I process all the numbers and I have not seen the number and its double, then I come here and I return false. So let me submit this and show you that it actually works. As you can see, it works. It's very fast. Um, this is a very general pattern in a sense. So what you're doing is you're processing an array of numbers and you're asking if the same number exists, if it is double exists, if the half of the number exists. So these are all searching problems, and hash sets are very good to process and implement these kinds of applications. Obviously, we are using extra space when you're using a hash set. You are using extra space. So if the question asks you, can you implement this same question without using extra space, then there is a solution. n log n solution, you have to first sort, and then again do the same thing. As you process the number, search if the double of the number exists in the array and half of the number exists in the array, which also takes log n time, because then it would be, the array would be sorted, and you can do this in n log n. So n log n time sorting, and then n log n time processing. So that could also be another solution. But our goal in this lecture is to show you how to make use of an hash set to solve these kinds of problems in expected order and amount of time. So if you have any questions, please leave them in the comments section.